I will be doing group work 7. It's called Salmonella Fest. Suppose that 1 out of every 4 eggs has salmonella, and that you are a chef at the Coffee Garden Cafe about to make a 3-egg quiche at the inspector's request. Let S be the random variable denoting the number of salmonella eggs that you put into the quiche. In problem 1, it asks, write down the probability distribution of S. In order to find the probability distribution of S, we first need to create a tree diagram. Now in the problem, it states that 1 out of every 4 eggs has salmonella. So we denote that for S, there's one. For the first egg, there is a 1/4 probability that it does have salmonella, and a 3/4 probability that it does not have salmonella. Now we move on. To the second egg, and the reason I say second egg is because each egg is independent from each other. So that means if you look at the one with salmon, if the first egg has salmonella, the probability of the second egg having salmonella is also 1/4, and the probability of a salmonella egg having the second egg not having salmonella is 3/4. Because it is independent, it has the same probability. Now we do that for the third egg as well, and now we can find our probability distribution of S. So we have our values 0, 1, 2, and 3 because S is equal to the number of salmonella eggs into the quiche. So the probability that there is a 0 number of salmonella eggs in the quiche is 3/4 to the third power, or 3/4 times 3/4 times 3/4, and the probability of that is equal to 0.42. For one salmonella egg in the quiche, we would have to multiply 1/4 squared time 1/4 times 3/4 squared, and we would add the same multiplications 2 other times. It's because there are 3 instances where there are 2 eggs in the quiche, 2 salmonella eggs in the quiche. So, and for the and if you go down to the second, to find the probability of 2 salmonella eggs in the quiche, we would multiply 1/4 squared times 3/4, and we would add that twice, because again there are 3 instances where there are 2 eggs in the salmon. There are 2 salmonella eggs in the quiche, and to find the probability of the third one, we need to cube 1/4 to get 0.016. So in the second problem, it asks, what is the probability that the quiche contains at least 1 salmonella egg? So since we already found the probabilities of the quiche containing at least 1 salmonella egg, we can denote that the probability of at least 1 salmonella egg in the quiche is equal to 0.42 plus 0.14 plus 0.016 is equal to 0.576, or approximately 58%. And the probability that, and for the third problem, the probability of the third problem is asking what is the probability that the quiche contains at most 1 salmonella egg. Since we've already found it again, we can just denote probability at most 1 salmonella egg is equal to 0.42 plus 0.42 is equal to 0.84, or 84%. We can say that because at most 1 salmonella egg, we would just take the values of S S equal to 0, the probability of S equal to 0, and the probability of S is equal to 1, and we just add it together to get 84%.